Hello everyone, I'm Bastien. I am a developer. I love refactoring, and I'm with Rémy today.
Hello, I'm Rémy Sanlaville. I am a developer too, and I am a huge fan of extreme programming and software craft practices. And we are both working at Orange, a French company, French telecom company.
And today we want to talk about refactoring and how we do this thing, and show you some tricks and maybe help you to see refactoring differently. But first, we have a question for you. How do you feel when you have to refactor some code? So just take a few seconds and feel how you are when you have to do some refactoring. And for us, actually, it's not only fond memories. How about you, Rémy?
Yes, I do not have a lot of good memories. It was hurting and not really pleasant. Now it starts to be better. And what I expect some real good crafter like Adi or Nicolas who enjoy to play with difficult legacy code. Most of the people find it hard and they don't appreciate it. And you, Bastien?
I have a few memories where I was really scared to start refactoring some piece of code. I was not sure where to start. I was not sure how it would end, and it was a bit difficult to really go into these tasks. And well, things have changed.
Yes, and indeed, when we have to refactor legacy code, many of the problems are we will succeed. How long will it take? And where do we start?
And because it's quite complicated, we have been used to not succeeding in refactoring, being scared, and we have kind of sort of learned of being helplessness is facing when facing this thing. And because we feel helpless, we are not really eager to start a new refactoring. Sometimes we even want to do the refactoring even if the code is not good, and that's a shame because we really think it should not be this way.
Yes, it's not a good thing because it's our job to be able to do that. And so it should not be a pain and should not hurt. So we rather think that it should be enjoyable and we must have a good experiences. It must become a second nature. So for today, we want to share how we do with Bastien. And we won't see a polished predefined demo, but more a refactoring journey. It will not be a receipt, but a way of thinking of how we do this now with Bastien. So we propose to go inside the code, and let's start with the election kata.
Yes, so I'll share my screen and show you the code for today. So like Rémy said, we do not pretend we know how to solve this kata. Actually, we do not know. And we wrote it for the occasion. We have played a bit with it, but we are not sure how to really refactor this piece of code. And well, maybe it won't seem magic at all, but what we really want to do is show you how we're going to pair together and what are the questions we have and how we solve the problems we face. Before we start, maybe I'll just introduce the kata very quickly to you. We'll show you how you can play with it later with a link. It's on the GitHub repository. And so this kata is about election. We have some tests, which is cool because every code you have does not necessarily have some tests. Here we have a good coverage of the code. What this code does is that it can compute some election results. So we can see that we have a list of electors, maybe, yes, something like this. Then we create an election, we register candidates, then everybody votes for someone, and then we get results. And actually, we have another test here with another way of computing elections. So we can see that we can compute election without districts, and we have another computation where districts are involved. So some people can vote for candidates, and not every candidate can present themselves to any district. And we have a different result. So let's look at the code. It's, well, I think that it's quite realistic. I have seen some code like this in production. It's not very ugly, but it's not beautiful either. So when facing this, some people maybe sometime would say themselves, that's okay, we can leave it this way and we can just continue working with this kind of code. Now, the thing is that I don't like this because I can feel that it will be quite hard to introduce new features or maybe to make sure that there are no bugs in it if we just make little changes. How do you feel about this, Rémy?
Yes, when I see code like this, I always ask myself if it's readable. It's not very, very readable, and if it's easy to add new feature, as you said, and I don't think that it's very, very simple and can be hard. And also, I don't see some the domain very well, and also the knowledge why people use this or not. So yes, I think that we can do better. We can see better code, and it's more procedural codes. So I think that we can do better for this. So let's try to refactor it.
Okay, so the first question when I start with some code like this is, where do we start? And
yes, yes. For
so
me, we have different tools in our toolbox, and one we can start with the first one that ask the IDE to help us. So perhaps he can guide us for different problem he can see. So we can perhaps start like this.
Yes, let's do that. So let's use the tool. So first one in here is this list that can be final. Okay, why not? Let's do this. It's a very little change. Let's run the test again just to be sure that we are not breaking anything. We have tests, so we are going to use them a lot. And we will run them very often.
Yes, it's important to be safe. So it's nice to have test for that.
So I have an unused parameter. Maybe it could be used in the future, but right now we don't need this and it's unused. So let's remove this.
Yes. It's better to remove all the noise when we want to refactor.
Yes, so here I could replace this by lambda. Let's see. Yes, that's better. Here we have a for loop that could be written differently. So this is kind of an old school way to write loops with index and all. So let's change to something more readable. We have the same thing here. We have a typo here. Let's rename this thing. So each time I'm doing a change, I'm running the test. This way we are sure that we're not breaking anything. So we are just making very little changes. And even if that's not a lot, the code is already better than it was before. So that's cool. So what do you do then?
Right. So next, I think that the code is very big, and I feel not very comfortable to change a lot of things in the same time. I prefer to make small baby step. So perhaps we can start by have a better look and understand of each methods, and try to see how we can reduce the scope.
Okay, so you said the code is big. I remember something when I started. So that's 100 lines, well, a bit more, but that's not a lot. Yeah. And when I started, I remember once at a job interview saying that below 1,000 lines, it was very small code. So just to say that what is big and what is small really depends on what you are used to. So yes, I agree with you. It does a lot of things, and at this point, I do not like to read the code and to try and understand what it does, because it can be quite long to do. And so I'd like to take some time just to see what it looks like, and if we can see patterns and things that could be maybe, well, a bit alike, or if we can figure out something just by the structure of the code.
Yes, I like to have a big picture of what we can see, if we can see some patterns. Yes.
Yes. So you said you want to see what methods we have, so we can start with a constructor, which is simple. We have an add candidate, which is rather simple. We see that we have hard-coded values here. It's probably something that we will want to fix at some point, but let's see that for later. Then we have a vote for method, and we have a big if here.
Yes.
So we have two cases, and it depends on with district. So with the test, we saw that we had something that computes selection results with district and something without district. So here we can see this very clearly.
Yes.
Let's see if by any chance the results method has the same pattern. So we have here a big if again, a big else. So you said that you want to work on smaller piece of code, and maybe to start, we can decide to split this with district and without district strategies into two pieces of code and just work on one.
Yes, I think that we can make an hypothesis that the code is used for with district and without district. So we have two strategy, and we can split this into two different parts.
Now, the thing that I don't like to do is split some code too early. And maybe it's too soon to split this thing. And I don't know. So I say, let's do that. Let's work on a smaller piece of code once we have separated the code. And then maybe later we will join again what we separated.
Yes.
Because
yes,
when you
we have different possibilities, and we don't know what is the best. So perhaps I think that it's quite nice to start with one and to be very comfortable to come back if it's not the good way.
Yes. If we do it with very little steps, it will be quite easy to come back to the initial state. So let's do that. So maybe first, we saw that we had three public methods: add candidate, vote for, and result. Maybe we can see if we can make the code show that there are indeed two strategies in the add candidate method.
Yes.
So we add an official candidate, we add a candidate, and then we have vote without district and vote with district. So maybe we can actually split this thing into. So let's try. We have tests, so we can maybe force this thing.
Yes. I like to see when we have duplication, so we can really see the patterns.
Here we are just relying on the name, and we hope that the fields are correctly named. It seems to be the case. So let's see if I can make a change here. And so we are changing the add candidate method, and we can now see that we have two different ways of adding a candidate when we are dealing with an election with district and we do not have any district. So here we still have some code in common. And if you really want to split this thing, maybe we can introduce some duplication.
Yes.
And maybe, too bad, tools are not helping me here. So I'll do this manually. So we intentionally added some duplication because we want to make sure that we're going to work on a strategy with district or without district. I don't know which one we will pick, and not have an impact on the other one.
Yes, and perhaps we can start to extract some methods.
So yes, let's do this. So this would be add candidate
without district.
And this one with district. Okay, so let's maybe do the same thing for vote for.
Yes.
Okay, so here we can really see that we have the very same structure for all this one. And let's do the same thing with result. So
Yes.
result, we have some stuff in common here and some stuff in common here. So let's do the same trick and again, duplicate some code so that we can make changes.
Easy.
So I think that now my tools can help me. So I can move this block into both if statements. And here I have a return that I could move also. So let's just cancel what I just did. I didn't run the test, by the way. I forgot that. So let's run the test again to make sure that everything is all right before we do this. Yes. So I would like to duplicate this whole block here into my ifs, which is good. And now I can just duplicate what's above here in both ifs.
Yes, it's a shame that IDE don't help to do the same, to split.
Yes. And I can run my test again.
Okay.
And now I can do the extraction like we did before. And then we will work only on one strategy. Doing this is a good way, I find, to learn how the code works and what it does exactly. Because now we just know that it's something that computes election results, but we don't know really how it works and what choices were made before. And so this is a good way to learn. I'm always more comfortable with doing things on the code, touching the code, making modifications, making changes, because reading code is boring and I don't learn very quickly when I just read. So yes, that's not a good method name. What would be a good method name without district?
Yes. Okay, so now we can see the patterns for 3 of the methods. The results, the vote, and the candidates, they are all the same. So we already see that we have 2 strategy, and we always split if we have a district or not.
Yes, and so now that we have done this, I'm just wondering here we have votes without district, votes with district, and well, maybe, I mean, very likely votes without district are not used in the vote with district strategy and the other way around. But it's quite hard to be sure. So what I'd like to do here now is maybe clone this class and remove all the code that is tied to the election with district.
Yes, another way to see that perhaps is to comment, perhaps try to comment the line 9.
Yes, we can do
and
this.
We will see the impact in the code. So another way to see very quickly. So, yes.
So the compiler can help us to see.
Yeah, so just add without district, it's in red. Vote for and result without. So it seems that your hypothesis is right.
So yes, we're quite sure that we can do this change. And also we could decide to work on votes with districts, but I feel that it might be a bit more complicated. So let's start with something that is more simple and just try to learn from this thing.
Yes. So it's quite nice to isolate the strategy without district in order to just play with it and we will learn more things just by using this. Because if we try to refactor all in the same class, I think that it will be more complicated.
Yes, also one thing I'd like to check if maybe, so we got lucky here, votes without districts is only used in the election without district. Is it the case for candidate and official candidate? So if I just remove these fields, I can see that they are used nearly everywhere.
Yes.
So it's going to be hard to just extract some part of the code and have maybe an aggregation or something like this. So what I suggest we do is that we re-clone the class, and we're going to have introduce a delegate. And the elections will use the extracted class, and we will then just work on the extracted class. That will just focus on the election without district.
Yeah, good idea. We will continue to duplicate and reduce after, to expand and reduce.
So here I'm just creating a copy of the class. And so it's not some technique that I use too often. Most of the time I can just extract some class directly, but here we have some data structures that are used in both strategy, and this is why we really need to do it this way.
Yes.
And so now
perhaps we can start to clean the election without district to remove the vote with district.
I like to do this, but later, because right now this class is only dead code.
Yes, and we don't have the test, so I agree with you.
I don't have any tests on this thing. It's not used, so let's not just touch this thing. And what I like to do is to have the election class use this new class.
All right, yes.
So let's create one.
So yes, we will introduce it, and we will make some parallel change.
And we'll create it in the constructor. I think I can start with this. So it's the same signature, so I can use the parameters that are given here.
Yes.
And I can run my test again. I'm doing something that has no side effects whatsoever on the current class, so I don't expect to break anything. Now the add candidate. So we said we are working on the one without district. So I can probably just call the add candidate.
Yes.
Still doing nothing actually, so no side effects.
Yes, and
side effect on this class.
And we need to keep the method add candidate without district for the moment, because it will be used after with vote and results. So we can't, as we saw, that we need to change all before removing.
And so here, clearly, the idea tells me I have some duplication, but we introduced it, so it's okay. We can live with it for now. And then the results. So of course, I'm not going to want to call the results method without using it, but right now I'm just calling it to make sure that everything is green, sorry. And so now we want to remove everything that is related to election without district from the elections class. We only want to keep the election without district in the election without district class. So let's return here what we computed before. It should be green because it's only a delegation. We duplicated the code, so it's really done. And now, since we are not using any longer the registration of the vote and the candidates of the election without district, we can just remove code. So let's go back where we introduced election without district. I can remove this thing, and it should still be working. And this way we're going to do this completely, and we will be able to work on the election without district class. So it's very small steps, and one thing that helps is really focusing on when data is read and when data is written.
So I think that we have some unused. Now we have dead code. So
yes, so let's remove the dead code.
Yes.
Okay.
Okay.
Well, that's better. And at this point, maybe we can start working on the elections without district class.
Yes, we make an isolation, and we use a strategy like divide and conquer. So we divide the election with two strategies in one strategy. So now we can work just on a reduced scope. So perhaps a clean first vote with district, because we don't need it.
Yes, but before we clean it, we still need to deal with this with district flag here.
Okay.
So because we are in the election without district, with district flag will probably be false.
Yes, start by making.
I can stop and try to introduce this change, and just check if indeed we are not breaking anything.
That's good.
Yes.
And the ID will help us now because we don't need the.
So we can remove this parameter.
Exactly.
And so the idea won't help us because we still have this field and it's not helping the idea. So let's just inline this field. We don't need it.
Exactly.
And now we can use the idea because we can simplify this thing and we can remove half of the branches of the code. Not what I wanted to do.
No. Yes. Remove.
Okay. So now I have removed half of the branches, and of course half of the method are unused. So let's do the same thing that we did before, but with the method that have the with district. Okay.
Nice.
So here we have now a smaller piece of code.
I think at the beginning, perhaps we have the vote with district. I don't know if you can see vote with district. Why is it still? Yes. So we don't need it.
Good question. We saw that we don't need it on the method earlier. So it's only used in the constructor, and that's it. So we can remove it if you want.
Yes.
And let's make sure that the tests are still passing.
Yes, and now it's not used anymore, so we can remove it also. Yes, I prefer that.
So let's now just work on this new class and try to simplify how we compute the result and maybe how we compute the vote and see what it does. So let's use the same trick that before, and let's ask the idea where we can just make changes. So we can remove a parameter here that was only used on the other strategy. So let's remove it. And then here I have something that is initialized. I can probably fix something. So I can either remove the initialization or join the declaration in the assignment. I'm going to do this to remove code. I have duplication. It's okay. We introduced it. So where do you want to start now?
So for the beginning, it's quite simple for the moment, so I don't need to make some refactoring. for instance, vote for, perhaps we can inline the vote for without
Yes,
defects.
I was thinking the same about add candidate. We have here methods that are just calling other methods, so let's inline things.
Reduce the noise always.
Okay, so that's better. Same thing with result here.
Okay. So,
okay, a bit simpler. Good. So we have add candidate. It's quite simple. Maybe we just let it be for now. Vote for. Seems quite simple, but it has some index magic here.
Yes, and we see that we modify it with a set and line 25, and with add, we have two ways to change the value.
Okay, so maybe we can do something here, and we have the results, which is a bit more complex.
Yes.
So far we only did very easy things, and I don't want to do any changes. So let's keep doing easy things.
Yes.
And one thing that is easy for me is to see if I can maybe find some duplication or something that I like, or some patterns. And right now I can see one here. Actually, it's just this string here, and it's used in many places.
Yes.
4 times. And so if we look at it a bit more closely, we can see that it's the whole string format thing that is duplicated.
Yes, so perhaps we can extract it in one method.
Yes. I don't know how to name it, so let's name it format. And yes, I would like to replace every occurrence source. So that's a bit better. I know I can see that this is very likely to... It's really the same thing. So we are computing something and putting into result map. Okay. And maybe here we could have something that is also like, and so we have a number of electors here. Same thing. I want to remove complexity here, and I want to extract this thing into a method. So
I like to see the domain emerge, so I prefer to have a good names for that. Yes, number of electors is okay for me. And also we can see that in line 63 we have a format, so we don't know where it is used.
So it's only used here.
Yes, so it seems to be not used.
Let's try and remove this thing.
Yes, let's have a look with the test. So yes, it was a dict code. So
I really liked what you did here, because we make a hypothesis like this thing is unused. Okay, let's remove it, and we test it. Yes. And anyway, whether we right or wrong, we're going to learn. So yes, that's really about doing and not just reading, but using the code and running it. Okay. So here it might be a primitive. Okay, let's do that. And I see that we have also primitives here, here, and here. And I don't like primitive. I like primitives because I don't like when things can be null in the code. So maybe it cannot be null. I'm doing this hypothesis. The tests are going to tell me. So let's do this change. Because, well, actually I like Kotlin because when you do Kotlin, you know if things are going to be null or not. And in Java, you are not always sure.
Yes.
And so if we can help our future selves to be sure that this thing cannot be null, let's do that.
Right. So yes, perhaps we can also make a better name for this. Because it's not clear.
Yes.
So it's the number of votes.
Okay, so null vote, blank vote, valid votes, number of votes, and we have a computation here of valid votes. Is it used anywhere? So it's only written here and read here. So maybe we can just create a method that does the very same thing here, and that is the computation of the number of valid votes.
Yes.
So that's a bit better. We still have this big for loop with if, else, and other ifs that I like to change. But maybe to do this, we'll have to.
I have to learn something before. It's not clear for me. For instance, we have vote without district and we have candidates. I don't know if they are linked or not. So perhaps I prefer to learn about it, perhaps with other methods or later.
Yes, okay. One thing we can do too is here we have votes without district.
Yes.
And it's duplicated 3 times, so maybe let's extract it into a variable too.
Yes, it's quite simple, so we can do that.
And I just don't know what it is.
It's a current vote.
Number of votes, but
yes.
I don't know. So we don't know what is stored into votes without district, and the result method is not very easy to read. So, like you said, let's see where it's used, and if we can learn exactly what we store in this thing. So when we add a candidate, we use it, and we add 0. Okay. And when we vote for a candidate, we use it, and so we increment its value at some index. And sometimes we also add 1.
Yes, what we can see is that when we add the candidates, we also define a value for the vote. And here, when we vote, we also increment by 1. But we don't see that we increment here, you see?
Yes. So what you suggested that we change this thing so that it's more like this code?
Yes, to see the duplication and the pattern.
Yes, because in both cases we are adding 1 to the current value.
Yes, because here we have it seems to be that we have the duplication like when we add candidate and add 0, and after when we want to vote, we want to increment by 1. So we don't see this.
Okay, so let's make a change. This one is not an automatic refactoring. It's we don't know if it's going to work. So I have to compute the index of the candidate here. I don't know how to do this.
So
but it's already done here.
I think that you have to duplicate both of 24 and 23.
Let's do something like this.
Yes.
And maybe
we add before, yes.
And let's run the test and see if it's okay. So yes, here we have some clear duplication. So we don't need. Let's just remove the duplication of this because it's really not necessary. So let's invert the if condition.
Yes.
And unwrap this thing. And remove the lines. And in theory, everything is green.
Good. And so now we see the pattern also for the add candidates. So it seems that we have something that when we register a candidate, so we add a candidate and vote, set the vote at 0. And we see the duplication, yes, with the add candidates. So
okay, so let's do this. And then we have this thing here. I don't really like it, so I like to have a method for this one, which is vote for a candidate, actually.
Yes.
But we already have a vote for. I'm just going to call this vote. We'll see if we can find better names later.
Yes.
Okay, so this is better. Now we understand that we have a number of votes for a candidate into the vote without district field.
And what I understand here is that we have a link between candidate and vote with candidate, but because with the vote method and the register candidates, we still have both of them. So maybe an hypothesis that they are linked with the index
Yes, we're clearly using the index of the candidate here, and this index is used into votes without district. So it's very likely that they both have the same size and are very closely related.
Yes.
What do you suggest we do here?
So try to see where we can validate our hypothesis. So one thing is to find a for loop for that. So maybe in 45, yes, we have the loop. So if our hypothesis is true, we can replace this by the candidate list.
Okay, let's do that. Another idea is to also make an assertion and just add some code that check this and run the test. Like, for example, we would say, okay, we assert that this thing has always the same size than the candidate, and if it's true, then the code is passing. But let's do what you suggest. I like it. And yes, so they have the same size.
Yes.
What do you want to do then?
So then...
Oh, I see some duplication here because we have candidates.
Yes.
Get I, and here, same thing. So let's just... well, I can replace here by candidate. I have my a variable that is already named candidate here. And we are still using an index here and here. So maybe let's just move this code here. And I'd like to remove the index. I'm not really comfortable with using indexes on loops. So here we have the number of votes for the candidate that is at the index I. So I'd like to have something that is more clear. That is number of votes for candidates or something like this. So if that's okay with you, let's try and do this.
Yes, I like it too. I prefer to use the domains candidate rather than an index. So.
And so I'm not going to replace this thing everywhere because I don't really know what we are doing right now. So let's not take the risk of introduce a change that we don't want. Okay, so I have a number of candidates, the number of votes for a candidate that is at index I. Like you said, we don't like working with index, so maybe we can just work with the name of the candidate.
Yes, so perhaps introduce a candidate name here.
Okay. Yes, so let's introduce it here. So this is quite safe because I'm just adding a parameter that is not used. So we can safely assume that we are not breaking anything. And now let's use this name to get the index.
So the question is, do we have the possibility to find the index from the candidate? Yes. So index of candidates seems to be okay.
And now we can use this index here instead of the one we are passing into parameter. I think that we could have done it differently, but I don't know. This seems quite easy to do.
Yes, and we can change it later after if we want.
Yes.
So yes,
remove this one.
That's better.
And if we go back to the code, so we removed any occurrence of the index. It's only used here, and now the tool is helping us, and we can just have a for loop without indexing.
Good.
Okay, so that's better. So we saw that candidates and votes without districts are really linked.
Yes.
And one thing I like to use is not having primitives, but having concepts instead.
Yes.
And,
primitive obsession, I like to work on with domain and concept. So perhaps the hypothesis we have in the mind that they are very linked. So perhaps it's quite nice to, as before, to reduce, just to isolate just candidate and vote and work on it.
Yes, so let's do the same thing that we did before. Try to isolate these two fields, and see if we can move them somewhere else into something that would be, I don't know, candidates, vote of candidates. We'll see. We'll figure out a name when we are there.
Yes, we will reduce the scope again and use the strategy of divide and conquer. So continue like this. It's working.
So let's find the occurrences of candidates. So it's used here in this thing. So let's create a method for this thing.
Yes.
And actually, it's a new candidate.
So the idea is try to isolate all the candidates in methods, so we will be able to extract and delegate in a new class.
Yes, so we have isNewCandidate, which is a small method that is only used candidates, vote, which is using candidates and vote without districts, register candidate, same thing. So all these things are really linked, and we'd like to move them somewhere else.
Perhaps move it at the end, all what we want to move, to see it clearly.
Okay, number of votes. We can move it to. And then we have the result method, which is, sorry.
Yes, perhaps just a search for candidate and.
Oh yes, right. I have number of votes for candidates. So we want to move this one too. And yes, I also have this one, number of valid votes. So it's using official candidates, vote without district.
So we just we use also official candidates. So.
And I think that it's very similar to something that we wrote earlier.
Yes.
It reminds me of this one.
Exactly.
We get the index of the candidate and we get the number of votes. And I think that we do the very same thing here.
Yes. So it seems that we can use it. Just try this hypothesis.
And yes.
Good.
Okay, so candidate is now only used here.
So perhaps we can rename candidate by name first.
Yes, you're right. So what you suggested that we extract a method from this?
Yes, that we extract candidate names.
Candidates names.
And also okay.
So let's use the compiler again and see if everything is working as expected. So what we suppose is that if we comment candidates, official candidates, only the method below this comment.
Yes, it's not official candidate. It's candidate with votes. Perhaps move both just near. So yes. So
let's comment these things, and here, yes, we want.
Good. So now we can extract and delegate in a new class.
So we want to move the fields: candidates, vote without district, and all the related methods.
Yes, and the ID help us. It's in blue. It's all what we have.
And should I move number of valid votes? No, probably not.
I don't remember if it's inside the.
I don't think so. So this is a big move. I'm already not really comfortable with this one.
All right. We will see after. We can move it if we see that it's possible.
Yes. Okay. What do you want to call it? So it's something that holds the candidate names and votes for the candidates.
Yes. So I don't know. It doesn't really matter. Perhaps it's a record, or I don't know.
Okay, so let's call it, yeah, record.
I think that we can
voting record,
use,
I don't know.
yes,
Okay,
we can use
records.
a name, and we will learn, and we will understand what it is exactly after.
Yes, so it's recording the name of the candidate and the number of votes.
So just have a look that we move all we sugs. So you see, we still have some.
Yes.
No, it's not used anymore.
They were not removed, but they are all unused.
So yes, so we have moved.
Still passing. So I'm just going to delete all this code here.
Yeah, good.
And run the test again. And so now we can do the same thing again and work on a smaller scope here.
Yes. Good. So what we can try to do is to try to introduce the concept of candidate. So because we have a list of string, and in the primitive obsession, I prefer to see the domain. So I think that I will really like to see candidate entity.
Okay, so maybe we can rename this thing into candidate's name.
Yes, exactly.
And you like to have candidates. How do you want to do this?
So I think that I will use again the parallel change, and I will introduce the list of candidates. And I will try to encapsulate the candidate name first. So just as before, we will see where candidate names is used, and extract method and move it in the candidate.
Okay, let's do that. So let's create a candidate class.
Yes.
And
so just so search of candidate name where it is used.
Okay, like here.
Yes. So this is new candidate. So I think that we can try to extract in a method this.
I'm not sure.
Oh no, it's always, so we can move it. And so what we want to do is to make the parallel change. So we want to use candidate here.
So you want to use candidates instead of candidate's name. So let's start with where we had candidate names. It's always easier to start with where we add data and then go back where we read this data.
Yes.
So candidate's name is actually changed here. Add candidate. So let's do the same thing here that we did before. Add new candidate.
Right. And with the name. So perhaps we can name it. Yes. Okay.
Okay, maybe we can rename this parameter because
Exactly.
it's not really
the name.
Okay, so we are adding the candidate here. Candidate's name is used here to get the list of the candidate names. So maybe you want to make a change here, because the idea that you want to remove this field completely and replace it by the candidates field.
Yes.
So let's see how we can compute the names of all the candidates using only this list. Maybe a map would be the easiest way to do this.
Yeah. But you can change. You have to leave it, no? Okay, try it.
Return. So I have to
return. Yes, it's just to read it, so you can do it.
Yeah. But I will need something that gives me the name of the candidate, and I don't have it. So let's create a getter. This way I can create a map here that creates the list of my names. Probably something like this. And yes, it's Java, so I have to collect So it's working, and we are still using candidate's name at 2 places, here and here. Where do you want to start?
Never mind.
Okay, first one then.
Yes.
So here we want to see if we already have a candidate that is registered and that has the same name. So we could do many things. To implement this thing, let's do something very quick with a comparison. And implement a equals that is based on the name. It's maybe not the best idea, but right now it's the simplest way, and we will refactor this code later.
Yes. So start with the easiest and fastest way.
So let's implement equals hashcode and everything here.
Yes.
And again, I'm very happy we have test.
Nice, me too.
Okay, last place here.
And yes.
To get the index. Any idea of what you want to do? I would suggest that we just do the very same thing.
Yes. Change the name and use a stream.
And it should be working again. And at this point,
we use it again in last
candidates only here. Candidate's name, sorry, only here.
But so we don't.
Oh no, we are going. I'm wrong. We are using it here too.
Oh yes. So it's the same that.
And at this point, we can remove candidate's name. Okay, so we moved a list to another one.
Good. So now,
what would you like to do now?
So now we want to do something with the votes. So I think that we have different possibility here. I see two. So the first one is to move the votes inside the candidate.
Yes.
That's one possibility. The other one that we can try to keep also the votes, to have the history of the votes. So it could work also. And we see that here we have different possibility. I don't know if we have another one, but I can see two.
Okay, so you say we want to synchronize the indexes of these two lists and move the votes into the candidate concept.
Yes.
Or we could also have a list of every vote that has been made in a more event sourcing approach.
Yes.
Where you would have all the votes that are registered. So here it's a design choice.
Yes. And I'm not sure that we know what is the best, and I don't know if we have the best. It depends of the context and what if we have to add a new feature. Perhaps one is better than another, but I don't think it's a problem to choose one. And the most important for me is that we can change it easily if we see that it's better to do the other way.
Okay. So we're running out of time.
Yes.
I would love to continue, but unfortunately,
yes, I think that we have to finish. So I think that we understand, and it's clear for me how to continue. Perhaps what we can show that how commits to see that the baby step that we have done.
Oh yes. So we used a plugin, and so actually we were working using TCR. So every time we run the test, the tool committed for me, and we never broke any test. So I should have a lot of commits here.
Yes. And logs.
Logs, sorry. So we have quite a lot of
yes,
a lot of micro commits. So I don't know how many. I don't know if I can count them here.
I don't know. But what we can see that we have nearly 1 commit by minute or more.
Yes. So a lot of very small changes. And I really like it because if we broke something, we can easily find when it happened and what was the cause of the breaking change.
Yes. All right. So now we will switch to the slide.
Yes.
Okay. So
what we did here, we talked a lot about it, but we decided to learn what the code does and how we can change it and maybe how we could break it by doing things. We did not try to read the code. We did not spend too much time drawing things. We really just decided to do things to learn how the code is working. And this is something that is really important for me when I do refactoring. I am never stuck this way. Always keep moving, keep doing things. Even if sometimes it's not the right way to go, I will learn something, and this is what really matters.
Yes.
And another way to put it, maybe with a little drawing, is that we start from somewhere, and from this point, we have many options. And we decide to explore one. And from the next point, we have new options and some old options that we can still do. And we pick one and we go on. And this way of doing allows us to discover new paths that we might not have perceived if we decided to spend a lot of time thinking about where we want to go. So it's okay to have an idea of where you want to go, but I found it's really more easy to say, okay, I'd like to go there approximately. And so let's make one choice, one little choice, and then let's make another second little choice. And new paths and new solutions may appear to us, and maybe we will end up with a code that is better than we could have imagined in the first place.
Yes, and it's important to be able to do it in a safe manner. So we are very comfortable with it. So in order to have a protected environment, it's good to have tests, as we saw. So we can make some small step and to be sure that we are dealing in the good way. And also when we want to make it safe, small is good thing, so small is safe. And we can do it in 2 ways. One is by reducing the time. So as we saw that we make a lot of several baby steps. And the other way is to reduce the size, so to reduce the scope, and we use a divide and conquer in order to isolate some code and to work just on this. The other things to have is to master our toolbox. As we can see, that's really important to master our IDE, to master smell and patterns and principle. And we need to be comfortable with our toolbox and gesture in order to be focused as much as possible on what we are doing and explore. And a good craft master its tool.
Another thing that we did was making everything that is invisible in the first place visible. When we started, the concept of candidate was not here. The concept of these 2 strategies was not clear in the code. And we really strive to make sure that we can read these things very clearly in the code. And this is something that will really help us later when we come back on the code to understand what the code is doing and maybe introduce new features and fix bugs. Another thing that is really important is to be able to switch between two postures. Sometimes we just listen to the code and let the code tell us what we had to do, where good changes could be made, or what we could improve, or what was wrong. And some of the times we decided that we wanted to go this way. For example, when we decided that we really wanted to split the code in two, maybe it's a bad idea, we don't know, but we decide to do this. And at this point, we are not listening to the code, we are listening to our own experience and deciding that we want to try something to learn new things. So it's really about switching between the two postures. One is really listening to what the code is saying, and the other one is deciding where you want to go, what hypothesis you want to make and test on your code.
Okay, so let's conclude now, and I think that we have two takeaways. So the first one is let's go, mastering how to let go. It's really important not to have a predefined plan to follow. We think that we really need to open our senses, to listen, to feel the code, and let's be guided by what we discover. So we need to feel the code, to be in communication with. We think that the code is a living being, it's not static. So as the software, the software need to be connected with the wave in order to feel it and to see how to do. And we think that is the same for the code.
Yes, and the other thing, we didn't use the word during the refactoring, but I really think that thinking about mutations really help. Like Rémy said, if you consider that the code is a living thing, then it makes sense to consider that refactorings are actually very small mutations. And if we see refactorings as mutation, we can also see features as new mutations. A refactoring is actually a structural mutation, while adding a new feature could be made by behavioral mutations. And we have been experimenting this on new code. When we write new code, we try to make very, very small mutation and have code that is always working, that can always be delivered. And it requires the very same techniques that we use when we do refactoring.
Yes, and we would like also to underline that the continuous, we think that we can make an analogy with CI/CD, continuous integration and continuous deployment. And it was before it was hurting when we want to integrate or to deploy in production. And when it's hurting, a best practice is to do it frequently. So we don't have to wait until the code is too difficult to evolve and to make some mutation. We have to do it continuously. So we think that it should be the same for mutation than what it was for integration. We should do it continuously and all time. Okay, so now we can stop, and thank you for listening. And we will share you the election kata link. Okay, so we will see the link if you want to play with it, and if you have a feedback.